Surprise! I'm back. And one surprise for here is all three of these examples are quadratics. And I'm going to show you why. This one is a quadratic. It's a bunch of rational expressions to make a rational equation. And what we need to do is clear the fractions and it will turn into something with x squared. We notice that our lowest common denominator is x times x plus 1, so we're going to multiply all the terms by x times x plus 1. So x times x plus 1, x times x plus 1, and x times x plus 1. So this x plus 1 goes away, and this term will turn out to be 5x squared. This x goes away. You have to be very careful with this minus sign. So it's going to be x plus 4 times x plus 1. And this equals, both of these go away, just 3. So poof, our clearing the fractions works. And so let's just finish this out. So it'd be 5x squared, and this would be minus x squared, and 4x plus 1x, so minus 5x minus 4. I'm making sure this negative sign distributes to everything. And then I'm going to subtract 3 from everything, so minus 3 equals 0, because we want our quadratics to be equal to 0. So this simplified will be 4x squared minus 5x minus 7 equals 0. So lo and behold, this rational equation is a quadratic. Now we have our choice. We can say, okay, can we factor this? And we test with our x factoring. 4 times negative 7 is negative 28. And we want to see if there's anything that multiplies a negative 28 and adds to 5. And I don't think there is, because it would be 14 and 2 or 7 and 4, and there's no difference of those as 5. So our two choices are to complete the square or use the quadratic formula. I think the quadratic formula would be easiest for this one, because if you look, we'd have to divide everything by 4, then we'd have a fraction, and then we'd have to cut that fraction in half. Be all sorts of mess. So this one I think would be best to use a quadratic formula, but yes, it is a quadratic. All right, let's move over to this one. P to the 4th, p squared minus 144. What we need to look at here in both of these examples is the exponents. The 2/3 and the 1/3. If this is double this and then this is a constant, we can say it's in quadratic form. So we can say something like u equals p squared, because this would be p squared squared is p to the 4th. So we can just rewrite this as u squared minus 7u minus 144 equals 0. And then we see if we can solve this, but this, yes, is a quadratic. Look at this, 2/3 is double 1/3. We can say u equals x to the 1/3. And so this would be u squared minus 5u plus 6 equals 0. And this can factor. It would be u minus 2 and u minus 3 equals 0. So u equals 2 or u equals 3. We don't need to deal with the x to the 1/3 until the very end. So we have these two answers. And then we need to put this u back in. So we have, I'm going to go up over here, x to the 1/3 equals 2. Now the question is, how do we get this just to be x? We raise 1/3 to the third power, so we get x, 1/3 times 3 is 1, so it's x to the 1 equals 8. And that's going to be one of our answers. And then we get x to the 1/3 equals 3. We do the same thing here to the third power. So we have x equals 27. So all three of these examples are examples of quadratics. This was an example of one where you could factor it once you got it into U form. This was one where we couldn't factor it, but we needed to use a quadratic formula. And this one I haven't looked at too closely, but we look and see if there's factors of 144 that have a difference of 7. And I don't know them off the top of my head, but that would be something you guys can figure out. So I'll see you next time.